Hello and welcome to this short demonstration of my project with the title Development and Evaluation of an Agent-Based System for Autonomous Business Recruiting Tasks. My name is Alexander Hense and this work was carried out as part of my studies at the Chair for Technical Information Systems with the supervision of Sebastian Schmidt. The project aims to automate the sourcing and evaluation of executive level management candidates by using a system of intelligent agent guided by large language models, also called LLMs. Before jumping into the demonstration of the code, I want to give you a brief overview of the whole system itself. So the object is to develop an autonomous system that navigates public company websites, extracts structured data on top-level executives, and ranks suitable candidates according to predefined educational and professional requirements. To attain this, I built an agent-based system that leverages LLMs to mimic the judgment and decision-making of a recruiter, while operating at a much greater scale. The system identifies relevant individuals, parses information into structured formats, and ranks the candidates based on defined academic and career requirements. To achieve this, the system consists of two cooperating agents. On the left side, the sourcing agent, which handles web navigation, the content extraction, and profile structuring. And on the right side, the screening agent, which evaluates and filters the extracted profiles based on user-defined filters, like field of study, graduation year, or management level. The entire flow starts with a single start URL. Typically, it's a company's homepage and ends with a ranked list of suitable candidates in a clean structured JSON format. On the right side, I've listed the core components of, of the sourcing agent. First, the LLM model, which are the LLM calls that handle the both extraction logic and navigation decisions. Then the web requests that are managed by using Beautiful Soup, and link relevance is assessed using ranking prompts. The output is structured in a JSON object ready to be evaluated by the screening agent. Also, we have a token estimation to track the token that is integrated to monitor performance and cost per run. And all of this is implemented in a custom Python project without any external orchestration tools like LangChain. So all in all, this lightweight modular setup keeps the system flexible and transparent. Let's now switch to the execution of the system. Currently we're in the IDE of PyCharm with the Python file opened for the sourcing agent, and I will start the script by inserting the homepage of a company. In this case, I will use the Nordic Semi homepage, a producer of semiconductors from Finland. And once I hit enter, the sourcing agent begins crawling the site. So let's kick the agent off, and it searches for subpages that are likely to contain management information like about us or leadership sections. And behind the scenes, it downloads the HTML content of each subpage, cleans it, and sends it to the LLM. Or before that, it actually parses the HTML to get rid out of the noise and the irrelevant text. And the model then tries to extract the key profiles or the profile data from each page. And here you can see the current iteration. For example, the agent is now scraping at page let's say at this one, at now page Nordic semi, etc. And it scrapes the link. And if the model finds meaningful content, it prints relevant data found, followed by a JSON object. That means that it successfully extracted a name, title, degree, a field of study, and a graduation year. And if the page is not useful, it moves on to the next ranked link. The link prediction function ensures that we focus only on promising paths, avoiding pages like news, events, downloads, or calendars, so irrelevant subpages. Once some profiles have been collected, the agent moves to the structuring step. Here it calls the function that consolidates, as you can see here, it consolidates the raw results, removes duplicates, and sorts by position level. The cleaned and sorted output is now shown in this formatted JSON, as you can see here, and each entry represents a person, including the name, job, title, and education background. So these results are then saved automatically into a file named run structured results, where all the runs are tracked. We can have a look into this file. So here you can see that we have a timestamp, the iteration count, the duration, and the token count for all the intermediate results. So this is the final output of the sourcing agent. Now that we have the structured profiles extracted by the sourcing agent, the next step is to shortlist the most relevant candidates using the screening agent. The screening agent takes in user-defined criteria such as required degree, study field, management level, and graduation year, and filters the list accordingly. And here is a example of the input. So let's say we are looking for a candidate who holds a master's degree in computer science, has reached at least a director level role, and graduated no later than 2005. And now the input is handled here, and it's filtered through the LLM. And what we get is the final results for the top candidate, and also other recommended candidates. Then the top candidate here in this case is Vegard Wallen, in this case, that meets all the criteria and is now highlighted in the final output. And also to be mentioned is that this data came originally from the semi-structured paragraph scraped by the sourcing agent, and the screening agent simply makes it actionable by ranking and filtering based on our needs or the need of the user. I hope you like the demonstration. If you have any questions, please reach out either to me or my supervisor. Thank you for your attention.